just a little. Okay. Want to continue?
No, we're finally live streaming. Thank God. Three, two, one. Hello, world. Andy's still not happy. Okay, now Andy is happy. So we're talking about Java E and Docker today. So what's the main reason you guys are here for Java E and Docker? Like, what are you interested in? Just give me some thoughts and ideas. Just because of me and the book? Kidding me. Java and Docker? That's a great thing. So that's exactly what we're talking about today. And who has been playing around with Docker already? Hands up. 2, 3. Well, that's not a lot. So, but you all know Java E, right? And no matter what application servers you poor guys have to run on, give Wildfly a try. So it's wildfly.org. This is what we're using today to get you a little head start on it. And now it's on you, right? Just get started.
Okay, so welcome everybody. And I will show you just a little bit of how Docker works and how Docker can be used with Java and us, including me as a Java developer. How can we use Docker on our favor? So, since many of you didn't raise your hands to say that you have an experience with Docker previously, I will show you what is Docker about. So, for example,
Let me hold that one. And
it works. To give you a kind of hello world with Docker, let me increase the size of the font here. Okay. So suppose that I'm here using Macintosh hardware with, of course, running Mac, and I want to run a Fedora image on this computer. What I will do is type docker run minus IT. What does this switch means? It means that I'm using interactive mode and assigning a terminal. And I will specify an image and also a process, because Docker is oriented to run a single process each time. So in this case, I will run Docker bash. I didn't specify any version of Fedora, so it means that we'll run the latest Fedora version. So it's here. It was so fast. And you can ask, how do you mean? Are you running Fedora there? Yes, I can do the thing like that. It's Fedora. It built, it boot, and it's running Fedora very quickly inside this machine. How that was possible? Let me show you another thing before explaining how that was possible. Suppose that I want to run a previous version of Fedora, the Fedora 21. I can specify here the version. Wow, it was as fast as it was before. Fedora 21 release. What happened, what I did show you is explained on this image. Fedora 19. Since this image is not locally, okay, I don't have network connection, but since there is no image on locally, it will download the image from this repository, as I said.
So basically, for Java E developers, like the Docker hub where all the images are stored is kind of a Maven Central for all the images that you could just pull on demand, right? And this is basically what we're doing. We're having a client asking for a particular image, POM, whatever you name it, and we're running it on the Docker host and getting kind of a terminal on that host.
So, okay, once that's really easy to run the bash process inside my computer, I will show you how to run a complete application server. In this case, I will be using Wildfly, which is our Java E7 application. And you will see that I just need to make run, Docker run, interactive, the wildfly image, and let me see if I will have the, uh, I have the image here. Nope. Uh, Thank you. Mm, Let me see. Okay. I had the image locally, so it was able to boot the application server. And I didn't need to specify any operational system. I didn't had to install the JDK or JRE. I didn't need to set up an environment variable, download the wildfly. I didn't need to do anything like that because the image already contains all those parts needed to run inside it. Let me show you the example of the image. So what happens is that the images are layered. So once that I asked for the wildfly image, the layered file system of Docker has a layer with the wildfly installed, which runs on top of another JBoss image that contains the JDK8 installed, which was built on top of another image which contains the CentOS operational system installed. Let me show you the source code of this Docker image. To build a Docker image is extremely easy. What you need to build a Docker image is essentially a file called Docker file. And as you can see here, and I showed you, this image, the wildfly image, was built using the base JDK image from JBoss, which already have the operational system, already have the JDK installed, and it sets an environment variable. It downloads the wildfly, creates a folder for it, assign it the right permissions, and something extremely that make us have more attention is this following instructions. Expose the port 8080 and also the default comment. So you saw that to run Fedora, I specified the bash process. To run wildfly, I didn't need to specify any process because the image already says, okay, this is the default process that we will run once that you start this image, okay? And when I do like that, Docker run and the image, I can also, instead of run wildfly in interactive mode, I can run the wildfly in a detached mode. So this allows me to have the Docker running and have my terminal free to do all other stuff, like managing or access this wildfly image. For example, suppose that I want to list all the Docker containers that are running. I can do Docker PS. I have other containers running here as well. So you can see here a line. Let me make the terminal a little bit more readable. You see that when I ask it to run a new container, it created a new container with a container ID. You can see this container ID here, the name of the image, the default process or default command, I didn't specify, but it used the the process that it was declared on the image. It was created 17 seconds ago. It's up and running, and here we can see the port 880. So suppose that I want to access this wildfly. As I said, the this Docker process is not running on this machine because this is not a Linux. This does not use any Linux technology, but it's running inside my VirtualBox. Here inside VirtualBox is where I have the Docker daemon running. So when I ask it to create a new image or a new process, the Linux is already there running, and it just created another process inside it using the layered file system, and it's there. So if I need to have access to this wildfly, I can simply make localhost, because as I said, it's not running inside localhost, but I need to get the IP of that Docker daemon. With Docker machine, I can do things like that. Docker IP, the name of the virtual machine, which is instructor machine, and now I have the IP. So if you try to access it on port 8080, you will see that it won't work because Docker is very concerned about security. So even having the image specifying that the port 8080 exposed, when I'm about to create the container, I need to say, oh, I want to, with the minus capital P, I want to take all that ports that are declared, and I want to expose that to the world. So I created a new container here, and now you can see that this container made a mapping between the port 32768 to the port 8080. So and now I can use this port 32768 to have access to Wildfly. And this is something that's good because Docker manages the port for yourself, the port, the network, because it avoids a port collision. I can run this container multiple times, and it won't cause any port conflicts, because as you can see here, random ports are being assigned to it. Okay. As we can expose ports to the world, the same applies to volumes. As you can see here, this Docker container is running inside the daemon. But suppose that I want to have access to the file system. I can also specify switch to mount my volume, to mount volumes, local volumes inside the container. So everything that you need to run to make the Docker container as accessible, you need to specify it when we are creating the container. Otherwise, it's very closed. You won't have access to it unless you specify. Well, and you may be wondering, oh, but that's kind of tricky. I had to have Docker daemon running inside a VirtualBox, and that sounds like a bit of too much work to have the container, Docker container running on Windows or Mac, since it's a native Linux technology. In fact, that's not, because Docker gives you a tool called Docker Machine. which allows you to create Docker daemons for you. In fact, this Docker machine command allows you to create not only Docker daemons in VirtualBox on your local host, but allows you to also use another cloud providers, another virtual machine providers, and so it makes really easy for you to create Docker daemons running on the cloud, for example. So I will create a new Docker machine here for you, so you can see how fast is that. I need to specify here a driver, which will be VirtualBox because I'm running it locally, and I will give a name, both session. Yep. Create both session. What you are seeing here is that once that I specify the VirtualBox, it's creating a SSH key, because another behavior of Docker is that the daemon does not allow you to connect on the daemon unless you have the proper SSH key. So only the clients that have the key will have access to that Docker daemon that's running. So you can see here that I created a new machine. It's being boot. It's preparing everything that we need to run Docker. And once that it's ready, you will see that I can create, that I can access this daemon and start using it. A little extra information. When you need to run Docker on OpenShift v3, you don't need to worry about that, because OpenShift v3 is already prepared to run Docker containers natively. So that's why you don't have any specific driver for OpenShift. But anyway, you have OpenStack here. So what do I need to access that daemon? What I need to do is to have an environment variable that points to that Docker daemon. This tool called Docker machine provides the env command that gives me all the information to have access to that Docker daemon. I have here the IP, the port, where is my certificate path, and if I run it, my client will now send all commands to this specific Docker daemon. So if I list here all the processes that are running, you will see that's empty, because the other Wildfly process that I run before is running inside the instructor machine. And this is a kind of preview. I would like to invite all of you to our Docker lab that will happen on Wednesday on Hilton Franciscan. The rooms C, D, and E with Markus and me. I hope that Markus will answer any questions that you have.
Yeah, so this is actually a really short and very rough intro. Can you, Rafael, can you do me a favor and show that GitHub repository where we have the complete lab up? So if you're impatient, if you can't wait to learn more, and a more detailed hands-on lab with bring your own device approach, so you can basically run it on every Windows machine or whatever you want to know, just go to the Red Hat developers GitHub account. The repository is called docker-java, and you can absolutely follow the documentation link there. And if you need a little bit more guided approach, then just come to our hands-on lab tomorrow. I hope you don't have any questions. In case you have, just fire at will. I'm here for a bit longer. You have to run to your next session. So I think we're pretty done for now. Taking questions right now? Anybody? What? Oh, raffle. You never told me about a raffle, Andy. Okay, there's a raffle.
By the way, you can. I want